In this lesson, you'll learn to evaluate functions using synthetic substitution and determine whether a binomial is a factor of a polynomial by using synthetic substitution. How can you use the remainder theorem to evaluate polynomials? The number of international travelers to the United States since 1986 can be modeled by the equation t of x equals 0.02x cubed minus 0.6 x squared plus 6x plus 25.9, where x is the number of years since 1986 and t of x is the number of travelers in millions. To estimate the number of travelers since 2006, you can evaluate the function for x equals 20, or you can use synthetic substitution. Synthetic division is a shorthand method of long division. It can also be used to find the value of a function. Consider the polynomial function f of a equals 4a squared minus 3a plus 6. We're going to divide that by a minus 2. When we do long division, we ask ourselves, what do I need to take a times to get 4a squared? That would be 4a. And I have 4a squared minus 8a. And then we subtract. And of course, the 4a squareds cancel out. Minus the negative is the same as a plus. So we have 5a plus 6. And then we ask ourselves, what do I need to take a times to get 5a? 5. So I have 5a minus 10, and we subtract, and we get a remainder of 16. Synthetic division lets us complete the same process with a lot less writing. We always drop down the first digit, 4, because whatever is here always ends up being here. And then we multiply. 2 times 4 is 8. Add, multiply again, 2 times 5 is 10, and add, and we have the same remainder of 16. Now that we've done before, this is the new bit. If we do f of 2, every place there was an a in the original function, I replaced it with a 2. I have 4 times 4 minus 6 plus 6. I get, what do you know? It's 16. Notice the value of f of 2 is the same as the remainder when the polynomial is divided by a minus 2. This illustrates the remainder theorem. If a polynomial f of x is divided by x minus a, the remainder is the constant f of a, and dividend f of x equals quotient q of x times divisor x minus a plus the remainder of f of a, where q of x is a polynomial with degree 1 less than the degree of f of x. When synthetic division is used to evaluate a function, it is called synthetic substitution. It is a convenient way of finding the value of a function, especially when the degree of the polynomial is greater than 2. And remember, when setting up synthetic division, we start with our highest exponent, and this is written in descending order. And we count down, so there's 4, and negative 2 is the coefficient of x cubed. 1 is the coefficient of x squared. There isn't an x, so I need a 0 for a placeholder, and then negative 2 is my constant. I'm going to drop down the first number and multiply. 4 times 3 is 12. Add. 4 times 10 is 40. Add. 4 times 41. Add. And 4 times 164, and add, and we get a remainder of 654. So we just found that f of 4 is 654. We have a nice long division problem shown in the book, where they take the polynomial that I have written in the numerator here, divided by the one we have in the denominator. And remember, we put in whatever would zero out our denominator goes in the box, and we drop down the 1 and we multiply and add, multiply and add. 4 times 3 is 12, plus negative 20 is negative 8. 4 times negative 8 is negative 32. Oh, nice. We can reconstitute that answer, writing it back with exponent is x cubed plus 5x squared plus 3x minus 8. The quotient of f of x and x minus 4 is x cubed plus 5x squared plus 3x minus 8. When you divide a polynomial by one of its binomial factors, the quotient is called a depressed polynomial. From the results of the division and by using the remainder theorem, we can make the following statement. Since the remainder is 0, f of 4 equals 0. That means x minus 4 is a factor of x to the fourth plus x cubed minus 17x squared minus 20x plus 32. This illustrates the factor theorem, which is a special case of the remainder theorem. The binomial x minus a is a factor of f of x if and only if f of a equals 0. And you can notice that a depressed polynomial has a degree that is 1 less than the original polynomial. Suppose you want to define the factors of x cubed minus 3x squared minus 6x plus 8. One approach is to graph the related function. From the graph at the right, you can see that the graph f of x crosses the x-axis at -2, 1, and 4. These are the zeros of the function. Using these zeros and the zero product property, we can express the polynomial in factored form. This method of factoring a polynomial has its limitations. Most polynomial functions are not easily graphed, and once graphed, the exact zeros are often difficult to determine. The factor theorem can help you find all the factors of a polynomial. Show that x minus 3 is a factor of x cubed plus 4x squared minus 15x minus 18, then find the remaining factors of the polynomial. Well, this one went x cubed squared x constant, so we don't need any zeros for placeholders. So we can just drop down our 1, multiply and add, multiply and add, multiply, and hey! And we should have got 0 because it said show that, so it means that it is. And if I put it back in polynomial form, we have x squared plus 7x plus 6. So I'm looking for factors of 6 that give me a sum of 7. So 1 and 6 will work nicely. So that means we now know all three factors because we already knew from the problem that x minus 3 was a factor. So the polynomial x cubed plus 4x squared minus 15x minus 18 is completely factored when we write it as x plus 1 times x plus 6 times x minus 3. The volume of a rectangular prism is given by v of x equals x cubed plus 7x squared plus 2x minus 40. Find the missing measures. Well, we know how to find the volume of a rectangular prism, length times width times height, and they told us that x minus 2 is one side, so x minus 2 must be a factor of our function v of x. So that means we can set up our synthetic division, and away we go. So we drop down the 1, multiply and add, multiply and add, multiply and add. And we knew it should work because I said so. So if you get something other than a 0 here, check your work. Now we can factor the polynomial x squared plus 9x plus 20. So factors of 20 that give us a sum of 9 are 5 and 4. So technically, the way they worded their question, they said find the missing measures. So my two missing measures are x plus 5 and x plus 4. So just like when we're reducing fractions, we're always going to look to see if we can factor more. Factors of polynomials do not have to be binomials. So they have x cubed plus x squared minus x plus 15 has factors of x plus 3 and then x squared minus 2x plus 5. Which I don't think I can come up with factors of 5 to give me a sum of -2. So in this case, we would have a binomial and a trinomial as factors. In summary, the remainder theorem, if a polynomial f of x is divided by x minus a, the remainder is the constant f of a, and f of x equals q of x times x minus a plus f of a, where q of x is a polynomial with degree 1 less than the degree of f of x. Factor theorem, x minus a is a factor of a polynomial f of x if and only if f of a equals 0.